Welcome to the video lecture series for the course titled CSE320 Data Communications. As part of the proceedings of summer 2020 semester, CSE320 course will be taught fully online. I hope all of you have already watched the introductory video where we discussed about the course and other generic course details such as course syllabus, exam pattern and grading. If you haven't watched that video yet, I recommend you to watch the video before you watch this one. In today's lecture, we will start chapter 1 of the textbook we have mentioned in the previous video, which is the introduction. So, this chapter will consist of a total of 7 short videos, which will be covered during the first week, which is day 1 and day 2 of the semester. In the first day, we will cover these topics. The first one will be the introduction to data communications, which is this video, of course. In the next video, you will be discussed elements of communications and data flow and network types. And in the third video, different types of network topology will be discussed. In day 2, we will start with the introduction to OSI layer and the TCP/IP layer. And in the next video, you will be given a conceptual example of the layered communications and how the layered architecture works. And in the last 2 videos, you will be discussed about the functions of different layers in the OSI model. Along with the video lectures, there will be 2 MCQ type pop quizzes, one based on the contents of day 1 and the other based on the videos of day 2. So now let's get introduced with the content creators and narrators, starting with Ms. Sifati Jahan, Ms. Shakila Jaman, Ms. Arnisha Khondakar, and myself, Rasif Ajwad. So here's the day 1 and day 2 content map, where you can see which video will be discussed by which contributors. The first one, this video, is discussed by me. The second video, elements of communication, data flow, network types, will be discussed by Ms. Arnisha. The third video, which is the different types of network topology, will be sourced from YouTube. In the second day, you'll have a brief introduction about the OSI layer and the TCP/IP layer by Ms. Sifati Jahan, followed by a conceptual example of the layered communications by Ms. Shakila, and the last 2 videos where functions of different layers in the OSI model will be discussed is sourced from YouTube. Now, shall we begin? So in the basic part of data communications, we will start our discussion with the definition of data. So what is this data? In the Oxford Dictionary definition, you'll find data defined as facts and statistics collected together for reference or analysis. So, however, in computing, data is any kind of sequence of one or more symbols given meaning by specific act of interpretations. The quantities, characters, or symbols on which operations are performed by a computer, which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical, or mechanical recording media, is actually called data. However, different types of data can be interpreted by different form of interpretation methods. For example, the process of interpreting a geographic data will be different from the process of interpreting numeric data like financial or statistical data. So you can see the different types of data we actually encounter in our daily lives. They are geographical, culture, they can be natural data, they can be meteorological data, they can be statistical, they can be scientific, a lot of types of data. When data is interpreted to make any decisions, data has to be organized and classified, which makes it information. When data is organized in a way that is understandable and meaningful to the receiver, it becomes information. To translate data to information, there has to be several known factors considered. The factors involved are actually determined by the owner of the data or the creator of the data and the desired information. In networking, these factors are actually called protocols. We will discuss about these protocols in the next video. Now, Let's move on to the definition of data communications. Data communications is the process of using computing and communication technologies to transfer data from one place to another, or one device to another. There has to be some form of transmission medium involved in data communications, and they can be wired or wireless. For successful communication to occur, the communicating devices must be a part of a communication system made up of a combination of physical equipment, which is known as hardware, and also programs known as software. Now, let's move on to the characteristics of data communication system. So there are four types of characteristics that actually defines a data communication system. They are delivery, accuracy, timeliness, and jitter. We'll start our discussion with delivery. So when you want to deliver something, let's say a parcel of a book, or let's say it's mango season now, you want to send 20 kgs of mango to your friend's house. What you need to know is the exact address or the location of your friend so that you can safely deliver the goods, right? In data communication system, it exactly works the same. As a sender, you have to know the exact address of the receiver so that you can send or deliver the data correctly. The second characteristic is known as accuracy. Let's say your friend asked for 20 kilograms of mango, but you have sent him 15 kilograms of lychee. Although you have made the delivery, but it's not accurate, right? Same thing goes for data communication system as well. When you are delivering data or message to a receiver, it has to be accurate. It has to be what the receiver asked you for. If you fail to do that, your delivery will be okay, but your accuracy will be zero. The third characteristic of the data communication system is timeliness. Your data has to be delivered in time. If the mangoes you are delivering for your friend reaches your friend after 2 months, they will be very difficult to eat, to say the least. So that means timeliness is also a very important characteristic of data communication. The data you are sending as a sender has to reach the receiver on time. Although there can be some unexpected delays in the delivery system, but that should not be more than the defined protocol of the communication system. The next characteristic is called jitter. Jitter actually means variation in the time between the data packets arriving, which can be caused by network congestion or the route changes. So when you have a big chunk of data to send to the receiver, what the network can do is the network can divide the whole data into different parts, which is known as packets. We'll talk more about packets in the next video, but for now, let's just assume that packets are different parts of data. However, when the sender is sending these parts via the transmission medium, there can be some network congestion or there can be route changes. For example, let's say a data has 3 packets, packet 1, packet 2, and packet 3. What can happen is that packet 2 and packet 3 can reach the receiver timely, but packet 1 might face network congestion and reach the receiver after the receiver receives packet 2 and packet 3. So what happens is that there is a variation in the time between the data packets arriving. So this is known as jitter. The typical symptoms of jitter in the communication system include choppy audio, delayed or dropped calls. Now let's move on to the data representations. There are many forms of data representations. Some are really basic and some are a little bit intermediate. The first one we all know is the text form of data. In data communications or in networking, text is represented as a bit pattern, and the bits are only a sequence of zeros and ones, which is known as the binary code. The process of representing these symbols into different kinds of information is also known as coding. The next type of data is numbers, which is also represented by the sequence of bits, zeros and ones, and then comes images. For images, there can be different color schemes such as red, green, blue, which is RGB, or cyan, magenta, and yellow, which is CMY. Also, data can be represented as audio or video like this one. So, what's next? In the next video, you will be discussed different aspects of the data communications, different types of network, elements of data communications, how the data flow from sender to receiver, how many types of networks are there, and a lot more. So stay tuned and goodbye for now.